Hello, everyone. I'm Brady Volpe, founder of the Volpe firm and Nimble This. Thanks for joining us today. With me is John Downey, consulting network engineer at Cisco Systems. Welcome, John.
Hey, thanks, Brady.
Today, we're going to talk about a number of topics, including DOCSIS channel bonding. So, one of the trending things that we see going on is a cool article that came out. It's a study that says cable companies will soon have more broadband subs than video customers. So it talks about signaling a major shift in priorities for cable companies. Moody's says cable operators will begin in 2015 start serving more cable subscribers than video subscribers. The findings are part of a new Moody's Investor Service report. Couch potatoes are switching screens as high-speed cable subscribers overtake video. So this is talking that, basically cable operators are seeing a trend that customers, subscribers, are willing to give up video more so than high-speed data. And I think this is something that we pretty much have been expecting for some time. People are using over-the-top and are saying, I can live without video, so we're cutting the cord on video and we're going over-the-top. We'll keep high-speed data, and cable operators understand that DOCSIS is becoming more of a revenue stream for us, and so it's really driving the need for speed and need for channel bonding. And so this is really kind of something we're talking about and getting into really needing to understand the pros and cons for channel bonding and also some of the issues associated with that. So that's an important topic for us today, John.
Yeah, I agree. I mean, I said this years ago that cable companies can't be a dumb pipe. If we're just a dumb pipe, customers are just going to buy the speed and they're going to do over the top and bypass our video on demand, bypass this, that, and the other, and not pay for it. And that's what we're seeing now with the younger generation. I mean, they're doing over the top, the Hulu TV, Netflix. I mean, I think the cable company has won a battle with what was the agreement or the law or the court case that just came out with Arrow.
Arrow, yeah, and actually Arrow is contesting that. They're going back and still trying to fight that, and they're looking at the licensing rights, and so I don't think that case is quite over yet on the whole Arrow thing. So that's still going to be out there and still coming to see how that's going to end out long term.
Yeah, and I always say, we can do the same thing, and that's why Cisco started getting into something called Videoscape, the terminology to do over the top for the cable companies so we have better control, quality of service, and things like that. But you got to realize that this over the top is adaptive bit rate, so it'll change its bit rate based on what type of screen you're using and what type of speed you have available. But it's also TCP based. It's not real-time streaming video where it's UDP, it's TCP based. So that downstream flow is going to start creating upstream traffic. And that's what I got to worry about also is upstream congestion.
Yeah, and I think it's really important for folks to understand the difference between UDP-based, so when I'm talking with, if I'm talking with someone voice over IP, that's UDP. So my packets are continuously going. If we have uncorrectable code word errors or something like that, those packets cannot be retransmitted. Now, what you're talking about with video that's being TCP/IP based, that's completely different than UDP, where the packets can't be retransmitted, right?
Correct. I mean, it's like you're downloading a file when you're filling up your buffer in your PC or your TV or whatever, or set-top box, IP set-top box. So you're downloading a file, filling up the buffer, start watching it, and maybe it's still downloading as you started watching it. I even thought maybe this is a good play for Power Boost. Maybe if I use Power Boost in my modem where I can boost up to really high speeds for maybe 5 or 10 seconds, maybe I can fill up my buffers faster and get that over the top a little bit quicker. Now, granted, our speeds now that we're offering is 10, 20, 30, 40, 50 megabits per second, maybe even higher. But like I said, we can't just be a dumb pipe and offer higher speeds. We have to be able to offer quality of service, right? Or quality of experience, some people are calling it.
Yeah.
And now I'm getting a latency and jitter, things like that.
Yeah, and QoE is becoming a huge topic. The customer wants great service, that quality of experience, how we deliver to the subscriber. And so a big topic that's been on the SCTE list, if you're SCTE members, you read the SCTE list. We've been talking for a couple weeks ago, we were talking about impaired service and partial service when it comes to DOCSIS channel bonding. So it's something that we've been wanting to talk about for some time now. And you know, John, maybe you can talk about some of those items or lead us into that discussion.
Yeah, I mean, that's what this whole call was about, right? Was to say, all right, we talked about downstream, upstream bonding last time. It's great to offer more speed, more aggregate speed for everybody to share, or a bigger pipe for peak speeds. So I can offer maybe 300 megabits per second or 100 megabits per second. Or I just want to offer 20 meg, but I wanted to oversubscribe it to 200 people. So, I mean, I offer a bigger pipe at the expense of more downstream spectrum, because now I have to open up spectrum to have more downstream channels and do bonding, which is fine, but when you look at DOCSIS 3.0, a modem locks on the one downstream channel as a primary, and the rest of them are secondary. So what happens if you have Ingress on that one downstream frequency that happens to be the primary channel of that modem? Well, that modem loses its primary, it loses its sync messages, it loses its upstream channel descriptors, it loses all sync, so the modem has to re-register. Personally, I wish DOCSIS 3.0 would have had some type of feature where the modem had like a secondary primary. Sounds like an oxymoron, right? A secondary primary. But I wish, because a lot of times your 8 downstream frequencies will probably be primary capable. That way 2.0 modems can load balance between all 8. But for a 3.0 modem, it only locks on one of those as a primary. So if I have 100 DOCSIS 3.0 modems, they could be distributed nice and evenly at the 8. I could have, what, 12 on each downstream, maybe? Or I could have all 100 on the first downstream. Unless there's some type of feature in the CMTS to distribute the primaries, it doesn't really matter. 3.0 modems are kind of, you know, simple devices. They lock on a downstream when they start scanning, and they see if they can work. If they don't work, they move to the next downstream.
Now, if I have 8 downstreams, John, and maybe one of those downstreams, like you're saying, has some errors on it, really, what's the problem? I have 7 other downstreams that I can transmit the data, so my subscriber should be happy. This we would think would not be problematic for the DOCSIS network. So, my feeling, if I really don't understand how DOCSIS is working, is 7 channels or 8 channels is great, because I can have 2 or 3 or maybe even 4 of those 8 channels completely impaired, because I've got 4 other channels that'll transport that data without any problem, right? Isn't that a great thing about DOCSIS channel bonding?
So it's true and false. I mean, the more channels I have, the more redundancy I have for 2.0 modem. So if a frequency goes bad, a 2.0 modem will go offline and just find the next downstream. So cool. But for a 3.0 modem, if the interference is on a channel that is not primary, then yes, I'll lose some traffic, but the modem will stay locked. But if the interference is on a downstream frequency that's primary for that modem, it's going to lose sync, and it's going to re-register. And then what will probably happen, depending on the vendor, the CMTS vendor, he'll lock on another downstream primary. He'll say, all right, here's my wideband group I'm supposed to lock on. But he'll send a CM status message back to the CMTS to say, you're telling me I should see 8, but I only see 7. And what will happen is a lot of times that modem either won't come up on W online as wideband, and it'll do DOCSIS 2.0 again, or it'll come up P online, which is partial online. And even the problem with partial online is you still don't know if the modem is doing 7 channel bonding, so it dropped from the full 8 down to 7, or is it doing all of its service flows on the primary channel, even though 7 channels were available. So there's these settings in the CMTS, and there's misconception about what the modem's really doing. Even though the modem might be doing 7 or 8 channels, it doesn't mean the service flow is actually doing all 8 channel bonding. It could be it was forced to use the primary for all its service flows. So go ahead.
So I was going to say, how do I, as the cable operator, know exactly what I should be doing, and how do I start setting this stuff up to make sure it's working well, or how do I know that the cable modem's operating properly, and if I have these type of error conditions in my network?
So let's look at what I consider the 3 reasons downstreams would go bad. 1, the head end. The edge QAM goes dead. And if that's the case, you affected all 100% of the 3.0 modems out in the field, because the problem started in the head end. That's one problem. If that happens, then everyone gets affected anyway, so it's really not that hard to decipher or figure out. But what about off-air ingress? Now, off-air ingress could be LTE. So LTE, your 4G cell phones, long-term evolution. Some of the problems is right here, being too close to your cable modem. It's not really the off-air from the cell site, but really from your phone trying to transmit receive. So that could be creating ingress between, say, 700 and 900 megahertz, wherever the FCC has allocated spectrum for 4G in your neighborhood. So that could be causing problems. What about off-air ingress from digital broadcasters? So say Fox TV used to be channel 3 in your it could be PBS. PBS was channel 3 in your neighborhood analog, and then it went digital, back in 2009 or 6 or what the heck, when we went digital off-air. PBS could have went at 500 megahertz. Well, that off-air is 8 VSB. It's not 256 QAM like we use, but that off-air digital doesn't line up with our on-air cable channels. It actually overlaps 2 channels. So that off-air digital could be taking out 2 of your DOCSIS channels and you don't know it. Now, if it's out in the field, which it's legally there, but if you have a crack in your cable, every modem downstream of that crack is going to see that problem. So here's a case where a subset of 3.0 modems are going to have the same issue reporting back to the CMTS. So that clustering of modems can report back to the CMTS a CM status issue, and the CMTS can make an intelligent decision to make a dynamic bonding group just for those modems. And because they're all seeing the same issue, they could all be clumped or clustered into that same, we call it resilient bonding groups. But the third issue is, what if it's household issues? What if you're doing 8 downstreams and you have maybe a kink in your coax? So now you have a suck out at one frequency. And then your neighbor has the same problem, but it's not the same frequency. What if he has high-end roll-off? What if the next neighbor has a dog chewing on his coax, so he has a different problem? So now all these single DOCSIS 3.0 cable modems are all showing independent or different types of problems. Now the CMTS has to work harder to make a bonding group for each one of these individually. And now I start running to, is it stable? Is it the CMTS making a resilient bonding group up, down, up, down, up, down? Because it got good, it got worse, it got good, it got worse. So there's some manipulation I might need to do to settle some of those things down. So head-end problem, it's affecting everybody. Off-air ingress, it's affecting a clustering of modems. And that one I can pretty much put into a resilient bonding group. So we do have features, and other vendors also have features nowadays, that even though I'm doing more downstream frequencies, and in my mind, more frequencies means more problems. I mean, if you're opening up more spectrum, you have the more probability of some frequencies going bad. So that's kind of how I'm feeling, that once I start doing 8, 16, 24 downstreams, I better have a backup plan. Meaning I better have some type of resilient bonding group so some of these modems can drop to a subset, if you will, like a subset bonding group.
Okay, so we have a couple questions that came in that are really right on line with what you're talking about. The first one is, you've been talking about primary channels, and if the cable modem's on one of those primary channels that's impaired, how is the cable modem actually choosing that primary channel? And what's basically telling, who's choosing the primary channel? Is that the CMTS, and how does the cable modem know that it's a primary channel?
I mean, 3.0 modems are just like 1.1, 1.0, 2.0 modems. They have a scanning cable built into the modem, and they start looking for a DOCSIS channel. So they scan, and really this could be vendor specific. Where do they start scanning, and do they scan up in frequency or down in frequency? I've seen both. So if my first channel starts at 555 megahertz, maybe my modem scanning table starts at 453. So it scans 453, nothing. 459, nothing. 465, nothing, and it keeps moving on and on and on. It finds 555, locks, it's a primary channel, good, I'm going to stay there. The next modem could have the same scanning table. He's like scanning up, hits 555, stays there. The next modem, 555, stays there. So even though 555 all the way up to 6-something megahertz is all primary capable, they could all lock on the very first one and stay there. Because
so if you have 8 channels in a bonding group, those all could be primary channels?
And normally you would make them all primary capable because you still want DOCSIS 2.0 modems to use them for load balancing. You're not going to allocate spectrum and not use it to its fullest advantage, right? You're not going to say, let's make one primary and 7 of them are just secondary, because then the 2.0 modems won't be able to use them.
Right.
You know, spectrum is a hot commodity. It's hard real estate to give up. You know, you still fight with the video guys trying to get some of that spectrum.
Sure, makes sense. So another question that came in, and you were talking about, you know, as we start going to 16-channel, 32-channel downstream bonding, if the CMTS is still using only one primary channel, is it up to the CMTS vendor or the cable company to decide how many primary channels are used? So, you know, in the case of 16 downstream channels, I think maybe you've already answered this.
So let me add on to that. What I would say is DOCSIS 3.0 goes to 1 gigahertz. The modems can scan the 1 gig, but DOCSIS 2.0 stop at 860. So what I've seen is customers or cable companies that have upgraded their cable plant to 1 gig, anything below 860, they'll probably make primary capable because all the 2.0 modems and 1X modems can utilize them. Anything above 860, 861 center frequency and above, they may make them secondary only because 1, they know the 2.0 modems can't lock on them anyway, and 3, they're only going to be used, or was that 1, 2? I don't know what number I'm up to. Number 3. I don't know. I know only DOCSIS 3.0 modems can use frequencies above 860. So in that regard, maybe anything above 860 won't be primary capable. And maybe just a couple. There's a lot of different options there.
Right.
And anything below 860, you're probably going to make primary capable. Why would you use spectrum and not use it for load balance of 2.0 modems?
And the configuration of whether or not a downstream is primary capable or not primary capable is in the CMTS.
Correct. You're just telling the downstream if he's going to have downstream sync messages and upstream channel descriptors inside that downstream channel. I mean, one of the pitfalls to making a downstream primary capable is you're probably eating up about 4% overhead. So instead of the downstream being worth about 37 megabits per second, a downstream is only worth maybe 36 megabits per second because you're blasting upstream maps on the downstream to schedule upstream traffic. Right. So there might be a case sometimes where I have a customer that has all 3.0 modems now. So there's no need to make them all primary capable if there's no 2.0 modems because there's no 2.0 load balance. They're like, yeah, we have 16 channels, we're going to make 4 primary. RF channel 0, RF channel 4, RF channel 8, and RF channel whatever. It's 12 or whatever it is. Do you understand? Like primary out of the first one out of a group of 4, first one out of a group of 4, first one out of a group of 4. Then they're going to make 4 4-channel bonding groups, 2 8-channel bonding groups embedded, and then 1 16-channel bonding group.
Yep, makes complete sense.
A lot of flexibility there.
Okay, so I think we've covered downstream channel bonding pretty well. You ready to move on to upstream channel bonding?
Yeah. Well, for downstream, so let's recap here. More frequencies, great. More load balance, more speed, more aggregate speed for 3.0 modems. But the con here, so there's pros and cons. The con here is 3.0 modems only lock on one downstream as a primary. Now, I know Cisco now in our latest iOS, we actually distribute the primaries across those downstreams. So when a 3.0 modem comes up, say you have 8 downstreams, it locks on the very first one, we can intercept it and say, I want you to move around between these 8 so you're kind of distributed between the primaries. Now remember, their data is bonded across all 8, so who cares? But which ones are used as primary, I still do kind of care. I'd rather them be distributed in case one of those frequencies goes down, only that amount of modems will reset. Does that make sense?
Yep.
All right, so I think that's a good wrap up for the downstream resiliency.
Okay. So after one of our last Hangouts, we had a question come in from Danny, and he says they use mainly Cisco Euro DOCSIS 3 modems, so that probably makes you happy, John. And they say if a subscriber tells them that their service is unreliable, they look at the log files in the cable modem, and he sent me a log file here from their cable modem, they see a bunch of parameters in that log file that gives them concern. A number of these parameters are T3, T4 timeouts. We see a lot of those issues, and John, I sent you a copy of this. Some of the parameters that they weren't familiar with were some TLV11s, which are these are normally custom parameters for cable modems, so they're unrecognizable OIDs. They also see some sync timing failures. They failed to acquire QAM, QPSK signal timing, and they have dynamic range window violations. So Danny's asking if we could perhaps maybe shed some light on what these issues are in the upstream, particularly with respect to channel bonding.
I think this is a good segue into the upstream bonding and upstream bonding partial mode. And so let me give you a background real quick. Upstream bonding is actually more resilient than downstream bonding. The fact that a modem locks on the one upstream, it does its station maintenance, does its timing, its levels, it's all from its UCD, upstream channel descriptor, so it knows the modulation and it knows the frequency, but it also does the same thing on all the other upstreams in the bonding group. So if I have 4 channels in the upstream bonding, all 4, I don't usually like to say this, are primary capable, if you will. We don't really call it that, but they're all 4 doing station maintenance. So in regards to upstream robustness, if I lose one upstream frequency because upstream noise, suck out, ingress, CB at 27 megahertz, whatever, that modem can go into partial upstream bonding and never go offline because it's still doing station maintenance on all the other upstreams. Now remember, downstream is totally different, right? It only uses one as a primary. Here on the upstream, all 4 are doing station maintenance. So more upstream channels in the bonding group, the more resilient that modem will be to staying online. Now with that said, I've seen a lot of cases where sometimes these T3 timeouts, which usually indicate upstream problems, are not just because of noise, they're because of timing issues. It could be because your upstream mod profile is not appropriate. So one of the things I've seen with timing was modems had time offsets that were incrementing over time, and they would just keep changing, and instead of being 20 miles away, the time offset was indicating that it was 100 miles away. I'm like, what's going on? The modem didn't physically move, but its time offset kept incrementing, and that was a firmware fix I needed for the cable modem. But it was creating a problem with my map advance, it was affecting everybody. For upstream bonding partial mode, another problem with timing I've seen is if I try to get too aggressive with my map advance, I start manipulating my map advance safety, I change maybe my downstream interleaving, I change what I call network delay, some people call it CIN for connected internetwork, or I think it's connected internetwork delay, and I'm on a very short fiber optic link, or I'm even in a lab where I have no fiber optic distance. If I get too aggressive, I've seen where modems are missing their station maintenance opportunities and they're going into upstream bonding partial mode. So what I've done, and I've recommended lately, is you go under, for Cisco CMTS, show controller, cable XYZ, whatever interface it is, pipe include DYN, capital DYN, for dynamic. And when I do that, I can see my time offset that has been negotiated for all my upstreams under that cable interface. And I want them to be 2300 and above. If they're less than 2300, they're a little bit too aggressive. I've seen modems go into partial mode. And what I find is, if I look under show cable flap list, I'll see a lot of misses from those modems in the flap list. And a miss is usually indicative of a T3 timeout from the modem's perspective. So if you see lots of misses from the flap list or a lot of T3 timeouts in the modem, it could be your time offsets are a little bit too aggressive, or maybe you really are having a problem with time offsets incrementing over time, or maybe it just is a noisy upstream. You know, normally you know well that most T3 problems are upstream problems, right? It's usually upstream noise, timing issues, mod profile issues, tech is disconnecting the fiber, or whatever happens to be going on.
Right, and so you're talking about partial upstream. I want to make sure that we make clear for the listeners what we mean by partial upstream, meaning that, you know, if we have 4 channels in the upstream, that the cable modem can bond to. Partial mode means that instead of bonding to all three upstream channels, it may only bond to 3 upstream channels, and that's what you mean by partial mode, right, John?
Correct. Yeah. So what's interesting also is it can't go to partial mode unless it's fully registered first in the first place. Like, what if you had power level issues during registration? So now it might not even register 4-channel bonding even from the get-go because you had power level issues. So let's suppose, we'll take a step back, let's suppose you don't have power level issues. Your lowest value, your highest value tap in your cable network is a 23 dB tap, and you do all your math and everything looks fine, and the modem is transmitting 50 dBmV. We know 4-channel bonding max output 64 QAM is 51 dBmV channel. So let's suppose it's transmitting 50 dBmV. It relays that information back to the CMTS, and the CMTS is like, oh, you want to do 4-channel bonding, you're transmitting 50 dBmV with 1 channel, so I know you're actually within the window. You're below 51, so you're not maxed out. I'll let you do 4-channel bonding. Then the other upstreams will do their station maintenance, and now you're running into different frequencies on the upstream. If I locked on upstream 0 at 24 mega 50 dBmV, but what happens when it starts doing station maintenance at 38 megahertz on upstream 3, and that happens to be 38 megahertz? What do you think is going to happen to your power level?
Yeah, so
you're getting closer to the roll-off of your diplex filter.
Right, I was going to say that's a diplex filter problem, especially maybe if you don't have pre-equalization turned on in the upstream. You don't have the capability of the cable modem to compensate for the roll-off of the
Correct.
diplex filter. If you're in North America, you have a 42 megahertz roll-off at the diplex filter. In Europe, maybe
in
they
the modem,
could be
in
65.
the modem. But let's be straight. You and I both worked at Secor, and remember, we dropped a lot of our diplex filters 5 to 40.
Yes, absolutely,
right?
We did.
Because we were running into chrominance and luminance delay on channel 2 on the downstream.
Yes, we cheated a little.
Because our filter was such a brick wall filter, we had to open it up a little bit so that channel 2 wasn't getting a problem when we had 7 amps in cascade. I remember that well.
Yes.
That was, what, 15, 18 years ago.
It just seems like yesterday.
I know. So some of our diplex filters are 5 to 40, even though the modem might have a filter in it of 5 to 42.
Correct.
But our diplex filters in the plant can be 5 to 40. So a 30 megahertz center frequency is going to have roll-off. And what I've seen when I look at a modem's transmit levels could be 50, 51, 50, 53, meaning that last frequency near the roll-off has to transmit a little higher to overcome the roll-off. And it's still okay because it's within a certain window. And now we start getting into this dynamic range window, which you brought up.
Yeah, this is Danny's question. This is what he's seeing in the error logs of his cable modems that he's having problems with.
Yeah, and the DRW, dynamic range window, is 12 dB. So 50 to 53, that's only a 2 dB window, so who cares? So for him to see a dynamic range window violation, 12 dB, that's pretty severe.
Yeah.
But the caveat here is, I doubt he has a situation where one upstream's at 35 and the other one's at 47. That would be 12 dB delta between 2 upstreams. Your upstream can't be that disparate, right? I mean, it's 5 to 42 megahertz. I mean, how much
no,
is going to have in there?
DOCSIS, so he's 5 to 65. So
Good point. Good point. But still, 5 to 65. Think about it, really. I mean, upstream levels from one frequency to another shouldn't be off by more than a dB or 2.
Unless you have a suck out or you're really...
There you go. Exactly. If you have a problem, or if you have severe roll off or something like that. Here's where the dynamic range window is not 12 dB, when you start getting near the max output. So if I have a modem transmit at 50 dBmV, it's not 12 dB window from 50, 6 dB up and 6 dB down, because I know the max output is only 51. So now my window really is 51 down to, what's 12, 39?
Yep.
So it's not like if I have a 50 dBm transmit, I have a 12 dB window there, around 50. Because the end of the window has to stop at 51 because that's the max output of a modem with 4-channel bonding. So now my window has shifted down instead of it being 6 from the middle. Or you understand what I'm saying?
Yes.
It gets a little convoluted here, a little strange.
Yep.
So I have a feeling his problem was the modem was trying to register. It registered with too much attenuation, and the CMTS was you saying, oh, you have max transmit, you can't do full bonding, and I've run into this DRW issue where it was a firmware problem, and it was reporting a dynamic range window error when in reality it was just near max output to begin with.
Right.
But it was a firmware update and actually fixed it.
So this is a good example of partial service where, you know, maybe we have 2 or 4 upstreams and we can only get one of them on. The other type of impairment is an impaired upstream. So, you know, maybe you have 4 upstreams you're bonding to. The cable modem bonds to all 4 upstreams. So, you know, we can see that they're all online, but you have some impairment on one of those upstreams and you have a very high code word error rate, uncorrectable code word error rate. And this can really have a negative impact on the subscriber data. So I actually think that an impaired service can be more problematic than a partial service. Do you agree with that?
I agree. And you know, the problem here is mod profiles. The mod profile has many different bursts. It has initial maintenance burst, the station maintenance burst. It has the request burst for contention request, an advanced short and advanced long, an advanced UGS for voice. All your data is those last 3 bursts, advanced short, advanced long, advanced UGS. Most of your traffic is concatenated on the upstream, so a lot of your traffic will be using the long burst anyway. All your voice will be using the UGS burst. But the first 3 bursts in a mod profile are the maintenance of the modem. So a lot of people think, I'll use QPSK for the maintenance of the modem, make it really robust, it'll stay online, and then I'll use 64 QAM for the data, the other bursts, the short, long, and the UGS. That's
horrible idea.
Actually, yeah, it's a wrong way to go. The third burst in this mod profile is the station maintenance burst. The station maintenance burst controls levels, it controls ping DOCSIS, it controls the flap list, and it also controls or is monitored to tell when to put a modem in upstream bonding partial mode. So if the station maintenance is QPSK, heck, I know from years and years of experience that the cutoff or breakpoint for QPSK is all the way down almost 12 dB MER.
Yep.
So let me give you an example. That upstream frequency for upstream 0 for that modem is 18 dB. 18 dB, QPSK will still work. So modem ping DOCSIS will work. The flap list won't really say anything. The QPSK at 18 dB MER is still perfect, so it won't go into upstream bonding partial mode. So all these little nuances here are making it look more robust than it really is. But if it's 18 dB, what do you think is happening to your voice and your data at 64 QAM?
No subscriber data is going across that network at all. But your CMTS is saying
100% uncorrectable fact.
Yeah.
100% uncorrectable fact.
But the CMTS is saying, hey, everything's wonderful. My QPSK maintenance data is going through, no problem.
Exactly. So with that said, people are like, well, should I make the first 3 bursts in my profile as vulnerable as my data? I said, yeah, in a way, but Broadcom came back to us. Now remember, Broadcom makes the upstream chipset. They came back to us and said, we don't want anything higher than 16 QAM for the maintenance of the modem. So I'm kind of limited, and my recommendation is anytime you use 16 QAM or higher for the data, use 16 QAM for the maintenance.
Yes.
That way, it's a little bit more vulnerable. There's still a little window there, right? 16 QAM will break about 18 dB MER. 64 QAM will break about 23 dB MER. So there's a 5 dB window there that I could still have this corner case. Cisco stole this, and we're actually planning on implementing another feature to put modems upstream bonding partial mode based on user configurable thresholds. So don't just look at the station maintenance, look at the station maintenance MER, look at the data burst MER that's now being reported by the chipset, but also just look at the MER and my configured threshold, and I'll let you know when to put the modem in partial mode.
Right.
Do you understand? That way, like as an end user, I might say, if this upstream ever reports, and it's on a per modem basis, if this modem ever reports below 23 dB MER, put that channel in partial mode.
Right. Excellent
So
recommendation.
even though 16 QAM would still work, right? 16 QAM would still work at a 22 MER. maybe you let me set my own threshold so I can put it into upstream bonding partial mode when I feel it's necessary.
Right, because you know that you set the modulation profile to 64 QAM in that case.
Yeah.
So if you have 64 QAM data going on in your long and shorts, that's not going to support under 23 or so dB.
That's the long and short of it.
Yeah, that's the long and short of it, buddy. So we have a question that came in kind of along, since we're talking about modulation profiles. And it's asking, would there be any advantages to turning on dynamic interleaving for the station maintenance burst? So, normally we do dynamic interleaving for long and short, but how about for station maintenance? So
actually, I don't even know if we're allowed to, according to Broadcom. I mean, the station maintenance burst is so small to begin with.
It's like 32 bytes or something.
Yeah, I mean, the interleaving is really to create robustness to impulse noise. The station maintenance is so small, it's like impulse by itself. So to interleave this small packet and mix it up a little bit, I don't know that it's going to do that well. Like, I even shied away from interleaving on the short burst. But you and I have talked about it, and we feel it's no harm, no foul. We might as well put it on the short burst, even though it's only a short burst.
Yeah, and
I don't put interleaving on UGS though, because I'm afraid of latency or jitter.
Right. Yeah, we said don't interleave the UGS because it's so short.
Yeah. But yeah, the interleave is not going to do me any good. I mean, I usually recommend upstream interleaving, like you and I have talked about this on the short and long grant, for better robustness to impulse noise. So if I need to start opening up spectrum below 20 megahertz, like 18 megahertz center frequency, where I know there's typically impulse noise from electrical appliances, maybe I use upstream interleaving in the mod profile just for that channel.
Right. So another question that came in here. Let's see. Says that the interesting thing is that this didn't happen not once with 5x20 cards on the same plan. I suspect it is an RF problem, but do you have some tips how to find out what is causing this, and what would explain the thing with 5x20 versus 3G60 cards?
And what was the problem though?
Oh, we have a problem with upstream bonding on 10K since we upgraded from 5x20 to 3G60 cards. A small percentage of the modem won't come online and get stuck in a NIT-O. They eventually go online, but it can take several hours. I guess it was a two-part question. I missed that.
So 5x20 is all integrated, and we only supported upstream bonding with the 5x20H card, and it was doing upstream bonding using software. So you had to be really careful that you weren't jacking up your CPU in the line card to do upstream bonding. So personally, I don't even like to do upstream bonding on the 5x20 card. But it was all integrated. Now when you go to the 3G60 line card in modular CMTS with a DTI server, external timing server, and the edge QAM, the upstream bonding is still happening on the line card, but the problem I've seen with a NIT-O, now normally a NIT-O means the options file, right? You're downloading the TFTP file, the CM file, the bin, whatever you want to call it. So normally you would think, oh, maybe something's wrong with the CM file, something's wrong with the TFTP server, but I've actually run into this problem, and it was a firmware or iOS upgrade that fixed it. If the modem was using different modulation on the 4 upstreams for bonding, and the modem was near max transmit power, that's what the problem was. So if the modem locked on the upstream 0 at 16 QAM, and then it said, I want to do 4-channel bonding, but 64 QAM, 64 QAM, 64 QAM, 16 QAM, and the modem was already transmitting like 50 dBmV, that's when I was seeing that problem. And then there was a fix for that. The workaround right away was don't do mixed profiles in the upstream bonding group. But I don't like to say that either, because what if I'm doing dynamic modulation and the whole upstream 1 goes bad and drops to 16 QAM on the fly? I might need to bond 16 QAM with 64, 64, 64. You understand?
Yep.
But it was a firmware upgrade to the modem, and we made like a catch-all on the CMTS with later iOS to fix it as well.
Yeah, a lot of complex problems. So, all All right, we covered a lot of ground here. Anything else you want to cover on upstream channel bonding?
If max transmit for 4 channels is 51 dBmV, what do you think is going to happen if we do 8-channel upstream bonding?
Oh,
It drops to 48.
yeah.
So all these people complaining about transmit power or transmit levels, it gets worse with 8-channel bonding. So let me give you an example. I have a customer that's doing 4-channel bonding with 3.2 megahertz wide channels. I said, what do you think is better? 4 channels of bonding at 3.2 or 2 channels of bonding at 6.4? If he went to 2-channel bonding, he actually gains 3 dB in his transmit level. But it's still the same throughput because he went double channel width. I said, right, you're paying for a license for upstream channels that you're using at lower capability. I'm like, why would you do 4-channel bonding with 3.2 megahertz wide channels when you could do 2 channels, save some money on the license, still get the same throughput, and get more transmit power because you're only bonding 2 channels? Yep. So this gets into the power levels and stuff like that.
Yeah, and that's a big challenge for people when they start doing upstream channel bonding. They oftentimes don't realize that the maximum transmit level of the cable modems decrease significantly, and so that results in them having to move modems in homes to get them from behind splitters, rebalance the return, rebalance the head end. So, you know, when you're moving from DOCSIS 2 to DOCSIS 3, or if you're at DOCSIS 3 and you have not started upstream channel bonding, but you're going to do upstream channel bonding, you really want to look at the max transmit power of your cable modems. Any cable modems that are above 50 dBmV, you're going to need to take a look at those because your max transmit power goes down significantly, and that has big ramifications on your entire plant.
Yeah, so. And you and I have talked about this, modems and max transmit, even 2.0 modems. In the Cisco CMTS, we have an exclamation point. Some people call it a bang. So when you do show cable modem, you'll see the exclamation point next to the receive level, indicating the modem is max transmit, but it's staying online. Because we have other commands that would say if the modem is within a certain dB or delta of 0, we'll let it stay online, but we'll mark it with an exclamation point, and you can track it. Well, the question then becomes, how many modems with an exclamation point is legitimate or okay? I really feel that if I'm already doing station maintenance to potentially 30,000 cable modems, and all these modems that are in max transmit power are getting 4 or 5 extra station maintenance because the CMTS is going into fast mode, then I made my CMTS look like potentially 50,000 cable modems in regards to station maintenance. And I know you've run into this before when you had MacTrack, maybe? No, not MacTrack.
PathTrack.
But you had an application, I think, that was looking at...
Oh, the SigTech.
Yeah, on the SigTech.
We had DOCSIS on the SigTech. We were looking at timing offsets over many modems. Yep. Yeah.
So you saw one vendor was actually sending a lot more like station maintenance requests.
Yeah, like every second.
Yeah, a lot more. So you're creating more traffic in the background because you're allowing too many modems to be in max transmit.
Yep.
So I find this as what is acceptable. I'm trying to get customers to keep that modem count that has the exclamation point less than, say, 5%. Somewhere in that range. I don't know what a magic number is, but that's what I'm shooting for. And then they go to DOCSIS 3.0, now they have even more modems with the exclamation point.
Yeah, you have more upstreams. Yeah.
So yeah, we drug this one out pretty long, longer than usual.
44 minutes. Okay.
All right.
So you will be able to find these episodes. We're doing podcasts of these on volpefirm.com/blog. And we'll also be moving these podcasts to iTunes as well, so you'll be able to download those and listen to the audio versions of these. So.
I have to start singing?
What's that?
Do I have to start singing now?
Yeah. Well, you know, you don't have to worry about what you look like, at least on the podcast. All right. So thanks everyone for listening. John, thanks again for your time and all your good advice.
Hey, by the way, we should ask people to write in any topics they want us to talk about. So if we do this like once a month or so, you know, what topics are on the top of people's mind and what should we really cover? Something we actually know something about, maybe.
Yeah, well, that would be desirable. If we don't know about it, we'll probably just make it up anyhow. So. All right. Thanks, everyone. Goodbye.
All right. See ya.